Why was this PCB order put on hold even though the DRC passed? The problem wasn't a short circuit. Could it have been the silkscreen? On screen, a silkscreen line is just geometry. In manufacturing, it becomes real ink that has to fit into real physical space, with limits on clearance, registration, and print resolution. In this video, we'll break down real silkscreen issues found during manufacturing and the simple design checks that can help you avoid them. Here's our first real production case. The designer placed component labels close to an SMT pad. On screen, the layout looked fine. During engineering review, our team found that the clearance between the text and the pad was very limited. In another, the ink actually extended into the exposed pad area. Why does this matter? Silkscreen ink is not solderable. If it covers part of an exposed pad, it can interfere with solder paste wetting during assembly, potentially leading to poor or open solder joints. That's why silkscreen needs sufficient clearance from solderable areas. When the clearance is too tight, the overlapping part of the character may need to be clipped or cleared to protect the solderable area. The key takeaway is simple. What looks like harmless text on the layout still has to fit within the physical limits of the manufacturing process. The second case is about character size and line width. The designer placed small reference markings in a dense area of the board. On screen, the characters were still visible and appeared well-defined. But some of the markings were already close to the limits of the printing process, with character height and line width falling below our typical design range. As features become smaller, ink spread, screen resolution, and printing tolerances become more significant. Very thin strokes can break up, while small characters can lose their internal details and become difficult to read after printing and curing. For AIVON's standard silkscreen process, text height is generally kept at 0.75 mm or above, with text width at 0.1 mm or above to maintain printability. The third case was different. The challenge wasn't physical clearance or printing resolution, it was design information. The order contained overlapping text across multiple Gerber layers, along with several markings that did not appear to serve a clear manufacturing purpose. There was another detail as well. Some order required a production tracking number, but no specific location or format was defined in the design files. When the same marking appears in multiple layers, or required information has no clearly defined location, the manufacturing team needs to confirm which information represents the actual design intent before moving forward. In most cases, our engineering team will flag the conflicting layers and contact the customer to confirm what they actually want to print. But if those extra layers are intentional and that's the effect you're going for, that's totally fine. We just want to make sure it's a design choice, not a file mistake. The fourth case goes beyond the silkscreen itself. Sometimes what lies underneath the marking can affect how it prints, or even how nearby components are assembled. In one order, silkscreen text was placed across an area with dense underlying features. Differences in copper and solder mask structures can create small changes in surface topography. When ink crosses these uneven areas, the transfer may become less consistent, resulting in broken or blurred markings. A similar consideration applies around BGA components. A solid, square silkscreen outline placed close to a BGA can create a localized layer of ink buildup. This may interfere with component seating or potentially affect solder joint formation. Based on production experience, engineers may recommend replacing a continuous outline with 4 corner marks around the BGA. This still provides clear visual identification while reducing the amount of silkscreen directly around the component. These are details that can be easy to miss in a layout review. The marking may look perfectly fine on screen, but its position can interact with the physical surface and with the assembly process happening around it. So, how can you avoid these issues before production? A few simple checks can help. Check silkscreen clearance around pads and other solderable areas. Make sure text size and line width are within your manufacturer's printing capability. When possible, avoid placing markings across dense or uneven areas of the board. Keep silkscreen layers clean and clearly defined, including any required production or identification markings. And one important point, manufacturing capabilities can vary between factories, so always check the DFM guidelines of the manufacturer you're working with. If you're not sure whether a marking fits your manufacturer's process, checking their DFM guidelines early or asking the engineering team to review it can save a lot of back and forth later. Silkscreen design has to work with the entire manufacturing process, not just look correct in the layout. These are not hypothetical examples. They come from real production orders and the engineering issues we encountered during review. And Silkscreen is just one category. In this series, we'll explore more DFM cases, from copper balance and solder mask to annular rings and layer stack-ups, and show what happens when design meets actual manufacturing. For more detailed breakdowns of individual production cases, visit the AIVON blog, where we share the engineering issues behind real orders. Catch the issue before production.